Hello, this is a tutorial on how to do the calibration calculations using Excel. So you can see I've got here some sample data that looks kind of like something we would have in the homework assignment. So with this data, I want to make the calibration plot so that we can know how to turn what we have is measured voltage here. So we're going to get a voltage measurement from our sensor, and we want to turn it into a temperature. And so we did an experiment where we put known temperatures on the system, and we recorded the voltages that go along with them. So we went 5 degrees, 10 degrees, 15, and up to 40, and then back down, so that we can do all of the different error breakdowns. So if I was to just graph this as is, you can see what we get is one series, I guess it's called in Excel, per column here. And so the data looks fine. We can see the scatter and everything in the data. But if you click on one and try to add that trend line, it just trend lines one column at a time. So the first thing we have to do for the deviation calculations and the curve fit, that's essential. We want to curve fit all of this data. And the only way to do it that I know of, at least in Excel, is to copy and paste. So I'm going to do that right down here. I'm going to copy it. And I'm going to put the true temperature here. Oops. Copy, paste. Stupid autocorrect. And then we've got the volts here. And then I'm going to copy this part here 5 times, one for each column. So first column, second column, cycle 3, cycle 4, cycle 5. And then I have to move all of these down correspondingly. So actually, I can just move them and then grab the next ones. Then down there, you can copy and paste or cut and paste. Lots of ways to do this. You could also come up with a clever indexing to change the rows into columns. That's easy to do, especially in something like MATLAB. But this works. You can see it didn't take that long. So now I'm going to make a graph, the calibration plot with this data. So I highlight it all. I go to Insert. Don't do a line graph. That's basically a bar graph. You want the scatter plot. So we want this scatter plot here. And we can actually, let's move it to its own sheet. Call it the calibration. So here is the calibration plot. Everything got really small. I can bump up all of these things. Actually, what I want to do first is chart design, quick layout. Actually, I think I can do it from here. Something like that. Something with axes, then that, and then make everything bigger. That's getting there. I think if I click on these guys, I can make them bigger too. What happened? These guys. Marker off. dimensions. Bigger. I'd like to use a plus or something. Sometimes it shows up, sometimes it doesn't. So there's my data. Looks pretty good. This is actually the measured, and this is temperature. This can move maybe over here or something. So we've got a decent looking plot. We've got labeled axes. We've got units given. It's all good stuff. So make sure you do all of those things every time when you make a graph so you don't look like a total amateur. Now we want the curve fit line, and that's going to be used for calculating the deviation, but this is the first thing we need from our calibration experiment. So if I right click on any of these data points, I can do add trend line, and you can see it adds it in there. It adds it to the legend. You want to make sure it's linear. Don't be tempted by any of these other ones. And you want this display equation on the chart so that we can see what the numbers are. There are ways to do the numbers directly in Excel, but this is usually the easiest. Don't display the r² value until you know what that means. We'll learn about that. It has to do with the accuracy of the curve fit. But if you put that on there in your report, I'm going to say, so what does that mean? And if you don't explain it, then don't. If you're not going to talk about it, don't put it on. That's the rule. So, so we want the equation, and that's the basics. So that's the calibration plot, and that's the first thing you would give to your customer. Say, look how well my temperature sensor works. So now we want to calculate the deviation so we can come up with the accuracy. So I'm going to go back to my data here, and what I want is the curve fit here. That would be in volts. These a little bigger, and then I can come up with the deviation, and that's also going to be in volts. So for the curve fit, I do an equation, and it's based on that the linear fit we just did. So equals to start the equation, and I want to do this one at the top using the data here from the top. It's just the temperature. So it's I'm going to calibration plot here. So 0.0678. Write that down over here. 0.0678. And this one plus 0.8819. I'm going to type them in, but I don't want to have to switch windows. Sometimes it does funny things. So for the equation, I can just put an equal sign, 0.0678 times x plus 8819. And these should match pretty close, right? Because it's the curve fit, which is just this line. So we're calculating the points where this line goes through at each section. So if it didn't, you probably have a typo. Oops, and back to this here. So now the deviation. Deviation is the measurement minus the curve fit. So I can do equals measurement minus fit. That's going to have units of volts as well. And then I can take these, you highlight the two, and then I want to repeat this template based on these columns, or all of this row for all the rest of the rows. So I grab the little square down here and drag it down. And now I've got the curve fit data. It repeats, so because this repeats, the curve fit data repeats, but we need that for the deviation. So the deviation would be 0 if everything was on the curve fit line, but it's not. So now we can make a deviation plot. So deviation plot will be this column on the x-axis versus this column. I'm going to hold down Control so I can get both columns without connecting them. And then I'm going to go to Insert, make that scatter plot again. I'm going to move this to its own sheet. Just going to make it all tiny. So then I will do, what's the order, I think? Quick layout, add some things. Home, make it bigger. That's not bad. If I do this, does it mess it up? Add that grid line. Yep. Make it bigger again. And then make this thing bigger. Marker options. Star. I like the ones where you can see the center. So X's and stars. Something like that. Looks pretty good. So that's my deviation plot. So the maximum deviation and the minimum deviation are my accuracy. I divide that by the output span. So I need to do that in Excel. So I will go back. I'm going to call this the deviation plot. And then I'm going to calculate the upper and lower bounds so that I can add them to the graph. So I'm going to graph them at 0 and 40 degrees Celsius because I want to start my dashed line here at 0 and all the way to 40. And then the first line is going to have points that are just they're just the maximum and the minimum. So equals, to do an equation, max is a function where if you give it a bunch of data, it will tell you the maximum. So I'm going to find all of this data. So there's my max, and then I can do the minimum equals min, open parentheses, and grab all of this, close parentheses. So I've got I want to graph this point and I want to do it again, so I'm just going to do equals the one above, and I can perpetuate that across. So I've got x values and the y values are the same, x values and the y values. So now I go back to my plot here, and I want to add those lines. So if I go to select data, I can go to add. I'll call this the max. X values are here. The y values are here. It tried to guess for me. I have to delete that. There it is. So now I can say OK. And I'm going to add the min as well. X values are here. Y values, we have to delete all of this. The minimum values. OK. And I can click. So I've got the original deviation, the max and the min. click OK, and then we see them as these little dots here. So we have to fix that. If you right-click on the dot, format data series, these things come up. So over here on the fill, we want to add a line, solid, but then we're going to make it dashed with that. We'll make it thicker, make it red, and then we'll turn the marker off. And we'll do the same down here for this guy. So I'm clicking on the minimum. It's these two dots. I just want to connect them with the line. So I'll go to line, solid line, dashed, red it's already doing. I think it was like 5 point or something, 4 point. That's good. And then marker, none. I'm going to make this one back to 4 point. So they match. All right, so there is my deviation plot. I would like to go to chart design, put a title here. If you paste this into a report, you may not want a title because you'll have a caption in Excel, in Word or something. But I'm going to put one in. And delete that. So this is deviation in volts. This one is true temperature. Celsius. Numbers are up here, but that's okay. And so now I have my accuracy limits shown on the graph, and that's the main thing that I want. So these are my accuracy limits in volts. I would divide them by the output span, which is going to be the maximum and the minimum minus the minimum of the measurements. And I could turn them into a percentage. So using the same max and min functions on this column, you could do that. So I will let you work that out yourself. All right, so I've got a calibration plot with a curve fit. I've got a deviation plot with limits shown. So I think that's a good place to stop for now. So let me know if you have any questions, and I will be happy to help.